and Nicole show.
We already explained our topics.
But in case you weren't paying attention, they're osmosis, diffusion, passive, and active transport.
We'll be explaining them right after this
Short break. Thank you.
Wow, wasn't that an insanely short break, folks?
Yeah, it really was. Next, we'll have Maya explaining diffusion. Maya, on set, please.
Maya, cut.
Cut. Maya.
Cut. Maya!
It's the movement of molecules in the cell that move from an area of high concentration to an area of low concentration. High concentration is where there's a lot of material. Low concentration is where there's a little bit of material. This is an example of diffusion. Once the food coloring hits the water, it diffuses. This diagram shows molecules diffusing in water. This also happens in our cells.
Osmosis and diffusion are very similar. The only difference is osmosis is diffusing water instead of molecules. Osmosis is important to the cell because it distributes nutrients and removes toxic waste. This is a picture of a hand before osmosis occurs. As you can see, this is a hand that has spent too much time in the water and gone through osmosis.
As the water hits the grape, osmosis occurs and the water molecules diffuse throughout the grape. Transport is the movement of molecules that do not require any energy to make their way across the cell. The molecules go with the flow instead of against it. Diffusion and osmosis are part of passive transport because they go with the concentration gradient.
As molecules enter the cell, they diffuse.
In the top half of the diagram, the cells are not evenly distributed. In the bottom half of the diagram, the cells naturally and easily separate themselves into even amounts.
Active and passive transport are opposites. Active transport uses chemicals as energy to move molecules across the cell. Unlike passive transport, active transport needs energy to go against the natural flow.
I don't want to go in.
You're making me use all my energy. On the right side of the diagram, the molecules are going with the natural flow. But on the left side of the diagram, the molecules are going against the natural flow and are being forced. On the left side is an example of active transport.
Well, thanks for watching our show, folks.
It was a lot of fun to film.
And anyway, we hope you tune in next time to the Nicole and Siobhan show.
Siobhan and Nicole.
It sounds much better, Nicole and Siobhan, doesn't it?
My name goes first in everything.
Not this time.
Active and passive transport are opposites. Active transport uses chemicals as energy to move molecules around. Active and passive transport are opposites. I can't say transport! And
She's breathing on my neck! You're like...
Because humans have to breathe, okay, Nicole?
I can't. Siobhan, I was about to breathe.
In the cell that moved from a...
No.